Welcome back. In last video, I have given some information about this course as well as the syllabus of first unit conservation laws. Now, in this video, before starting the syllabus, just have a look on the basic requirements which are helpful to study this unit. Okay. So first thing is position, rest, motion, distance, displacement, then velocity, acceleration, momentum, then force. So now the present unit is completely based on these quantities. So first thing, position. What is position? So position means it is a location where the object or body or anything have to be placed at a instant of time. Now I am going to place here a point, so this is a position. Now I am going to place a man here, so this is the position of that person. Okay, so like that, the position means simply it is a location or object where we have to put the particle or object. Next, rest. Okay, so rest means we are going to define this rest using this quantity position. Okay. Now there is a particle here at this present time. After certain time intervals, again the particle is at to the same place or positions. So then we say that the object is at rest. Okay. Now there is a person here. Now the time is over 9 o'clock. After 9:15, 9:20, 9:30, the person is in this position only. Then that we call it as it is at rest. So motion. The motion means, again we are defining this motion using this term position. If an object is going to change its positions at different interval of time, then that we say that the object is in motions. Now at present the particle is here. If it changes from here to here, okay, now it changes a certain positions, okay, it comes from here to here, then that means the object is in a motions. So and then the walking person or running person, so now he is here, after some interval it comes here, then that will say that it is in motions. Then distance. Again the distance is also defined based on the positions. Okay. That means how much distance it covers. Okay. Now there is a person, again I am taking here an example. He is walking. Okay. Now he is moving here and here and then he comes here. Now the distance means how much distance he has covered in an interval of times. How much distance? Now we have to measure along this path. Okay. Along this path we have to measure the distance. Okay. So that we call it as distance. And then displacement. So here again displacement is also defined based on the term positions. And distance and displacements are little bit similar. Okay. So that little bit similar means that is possible in case of linear motions. Now the displacement means here there is an object. Now it comes here. After certain time intervals it comes here. Okay. Now I am going to define displacement. Okay. So now the distance between, that shortest distance between these two positions, that we call it as displacement. Here we won't consider the path it travels, whether it goes like this or whether it goes like this, we won't consider. We are consider only the initial and the final position of the object and the distance between these two objects that we call as displacement. So the difference is what? In distance we are going to measure the distance along the path which it covers or which it travels. In displacement we are going to measure the shortest distance between two positions. We are neglecting or we are not considering the way in which it is moving. Okay. Next, velocity. Here velocity means, again it is defining based on the positions. Okay. Velocity means rate of change of positions. Okay. So now it is here the object I am considering here. After some time interval it comes here. Okay. Now this is the distance. We don't know how it is moving, whether it is moving linearly or circularly, whether it is moving in different paths, we don't know, but the initial position is this one, the final position is this one. Now this is the displacement. This rate of change of displacement or change of position that we call it as velocity. That means velocity is depending on the displacement as well as the time. Okay. So the expression related to that we'll see later. Next, acceleration means here to recognize is little bit difficult, but the mathematical form is the acceleration is rate of change of velocity, means in a certain interval of time how the velocity changes, that gives accelerations. Okay. So momentum is defined as the amount or quantity of motion present in a object. So momentum we are defining for moving objects. Now the amount of or quantity of motion present in body or particle or object, so that we call it as momentum. Okay. So force we'll see later using the expressions. Okay. Now all these terms we defined using these positions. Okay. The rest, motion, distance, displacement, velocity, acceleration, everything is directly or indirectly are depending on the positions. Okay. So first we have to clear about these positions, how to represent the positions. Okay. In which conditions the position terms are expressed in different dimensions. So like that, first we have to completely clear the positions, then the mechanics will be easily studied. Next, I am again starting from positions. This is important. If you understand this one, then the remaining part will be easy to learn. So position means it is a location. Here we are going to place a object, or it is a point where you are going to put a particle or object, that we call it as positions. Now the condition is here, these positions representing in three different dimensions. Okay. So here one more term is coming, 1, 2, 3. Three terms that are related to three dimensions. The first one is one dimension, two dimensional, three dimensional. So one dimension or one dimensional, two dimension and three dimensional. Here one dimensional means, here dimension means you can take it as a length. Okay. So length, here one dimension is one length is required. One length required means, so first I am taking an example. Example I am taking is thread or string. That means how it is. So this is the thread. Okay. It has only one dimensional structure, that is only one length. Okay. Now the length of this thread is about 50 centimeter. We can say that 50 centimeter length thread. We are not saying the thickness or we are not saying the diameter of this thread, just we are saying the length of this thread is 50 centimeter. Along this length we are going to measure the length. So this kind of structure or this kind of phenomena that we call as one dimensional. Okay, now the position representation of position in one dimensional space, that we call as space means 3 dimension. Okay, in one dimensional, now the object is here, now I will take this as x-axis, along x-axis, that thread is along x-axis. Now this is the position of the object. Okay, now this point I will take it as origin. Here this is 0. From here we are going to measure the positions. From here to here it may be about 20 centimeter. Okay. Now what is the position of the object? So it is at 20 centimeter. That means what is the x value? X value is 20 centimeter. This is the positions. Okay, so in terms of vectors we can write this position vector represented by r is equal to x I cap. I will write this position vector r equal to x I cap. X indicates it's a dimension, I indicates it is a unit vector that is represents along the x-axis. That also we are measuring along the positive x-axis, here positive sign. If you write minus, then we are measuring in reverse directions, in negative x-axis. Okay, now if it is changes from here to here, means from position r1, this I will take now r1 because the position changes. r1 to it is moving here, r2. Now r2 is the second positions, that means the object is in moving. Then this position is r2 is equal to again x2 I cap. In generally I am represent here r. Now the position are considering, so then it becomes r1 and this becomes x1, this is r2 and it is x2. Like that we are going to represent the positions and motions in one dimensional space. Next, two dimensional. Here two dimension means two lengths we are considering to measure the positions. Okay, so that is one is x-axis and the other one is y-axis. Here one easy example for one dimensional motion means I am moving along the thread. Okay, and moving along the thread, so that is the motion, one dimensional motions. That's same, and now I am going to place on a paper. Okay, the same and I am going to place on a paper. Now it is moving, we don't know how it is moving, but it can't fly or it can't pass through the paper, just it is moving on the surface of the papers. Okay, so here it is moving. So that kind of motions we call it as two dimensional motions. Now that ant or that object is here at certain time intervals. Now this we call it as positions. How to represent positions? Now here we are taking two lengths. We have to represent two lengths for these positions. One is along x-axis and the other one is along y-axis. Now, so this is x-axis positions and this is y-axis positions. Now the point along x and y-axis that will give the position of the, I will write here x1 y1. This is first position, x1 y1 is the position of this object in two dimensional. Okay, now so there is a vector to represent these positions, that is we call it as r is a vector that represents the positions. Now that vector can be written as r equal to x I cap plus y j cap. Okay, position vector, I am saying that this is a vector, position vector. For that we have to write in terms of vector notations, x I cap y j cap. Here what is x and y? X is the position along x axis, y is the position along y axis. So I cap and j cap are the unit vectors which represents along x and y axis. Okay, now this object comes here after certain time intervals, from here to here it will move here. Now the x and y positions both are changes. Okay, so this is x position and this is y position. Okay, again here I will write it as x2 y2. Now x2 y2 are the positions of the object after certain time intervals, then that is unit vector r2. Okay, again unit vector will change here, the unit vector is changes from here to here. Okay, for that r2 is represented as x2 I cap plus y2 z cap. So this is the first positions. For that I will represent it by a y1 x1, and this is the change of position in two-dimensional space, that is represented by a unit vector r2. Next, three-dimensional motion. So three-dimensional motion means, now here three lengths are used to measure the positions. Okay. How it is? That simply we call it as x, y, z axis. Now a bird is flying in a room. Okay. So example, here I am taking a bird or a butterfly is flying in a room. Room means it is three-dimensional space. Now that we call it as three-dimensional motions. Now this position is represented by three variables or three-dimensional coordinates, that is x1, y1, z1. The initial positions that I am writing, for that the notation 1 is ready. Okay. So that means, so x1 is the x length position, y1 means position along y axis, and z1 means, so here it is little bit difficult to represent the z direct three dimension in a two dimensional space. Okay. So this is z positions. Then the unit vectors, that vectors which represents this position, that is position vector, that is representing here r1 is equal to x1 i cap plus y1 j cap plus z1 k cap. Okay. So this is the representation of position vector in three-dimensional space. Now this position changes from here to here, it changes its positions. Now everything is changes, the position vector is also changes, the position which represents x-axis, y-axis and z-axis, that is also changes. Then we can write it as r2 equal to x2 i cap plus y2 j cap plus z2 k cap. Okay. So simply in three-dimensional space, three coordinates are required. In two-dimensional space, two coordinates are required. In one-dimensional space, one coordinate is required to represent its positions. Okay. So using these positions, now we can define the different terms, that rest, mass, motion, velocity, displacement. So like that we can define using these vector notations. Okay. So now rest. So everything I am going to define in two-dimensional space. Okay. Don't take much difficult or don't take too easy. So this is in two-dimensional space. I am saying this. Two-dimensional space are x and y. Okay. Now this is the position of the object. This position is what? It is along x1 and it is along y1. Then x1 y1 is the position. The position vector is represented by r1 equal to x1 i cap plus y1 j cap. Okay. So this is the position of the object. At certain interval of time it is here. After some more times this is again at the same positions. Then that position we call it as rest position. It does not moving with respect to time. Again after a certain time interval this is at the same position, then that we call it as rest. If it is changes from here to here, this is position vector, and here the position vector r1, this position vector r2. Then r2 is now x2 i cap plus y2 j cap. Then the position vector is changes, that means the coordinates also changes, that we call it as the object is in motion. Okay. Then distance is the shortest distance between two objects. Then velocity, I am defining velocity is the rate of change of positions. Velocity is the rate of change of position. Rate of change of position. Okay. Change of position is displacement. Rate of change of position is velocity. Okay. So how it is defining? Here the object is changing from r1 to r2, the x1 position changes from x1 to x2, y2 position changes from y1 to y2. In general, there is a change in x position, that we will take it as delta x, and in change in y position, that I will take it as delta y. Now the velocity is what? Rate of change of position, means whatever the change in position is there, that is with respect to time, that gives velocity. Now delta t I will write. So this is the velocity at an instant of time. In differentiation notations, I will write the velocity v equal to dx by dt into I cap plus dy by dt into z cap. At any instant of time, the velocity is, now it is dx by dt I cap plus dy by dt into z cap. This is the velocity. Next, acceleration. What is acceleration? Here acceleration is rate of change of velocity. Velocity is what? V. Here change of velocity is what? I will take it as delta v divided by rate of, means it is delta t. Okay, delta v by delta t, that gives accelerations. At any instant of time, the acceleration now represented by a is equal to dv by dt. Okay, but in terms of position vectors or in terms of notations, vector notations, we can write this velocity is also vector quantity. So it is d by dt of dx by dt into I cap plus d by dt of dy by dt z cap. So then d by dt, dx by dt, that we can write it as d square x by dt square into I cap plus d square y by dt square into z cap. Okay, this is second order derivative of position vector. So this is about accelerations. Next, force. Okay, before defining force, first take momentum. So this momentum is represented by p. Momentum means amount of motion present in a moving body. Okay, this is the meaning, but mathematically the momentum is the product of mass and velocity. It is a product of mass and velocity. Okay. So mass is the property or inertia of the object, so that is represented by m. The velocity is represented by v, so that is a vector quantity. Then momentum is a vector, p equal to mv. So this represents the momentum. In terms of position vectors, it is dx by dt I cap plus dy by dt z cap. So this represents the momentum of the object. So this is all the basic requirements required for this first unit, conservation momentums. That conservation momentum is completely depending on this momentum concept. Okay. So in next video we will start with conservation of linear momentum. Okay. Thank you for watching this video.